All right, guys. Welcome back to the other part of the session. So far we've discussed listing, sorting, constraints, using joins, union values, null values, alias. So I'm going to continue with indexes. So what are indexes, right? So let me come here. Don't worry, I will share this with us. So you can see indexes are special lookup tables that database search engine can use to speed up data retrieval. So now, say for example, let me do a new query, and then so let me say for example, we have this query, Control V, let me run it. All right, it will give the time it takes, right? You can see this is the time it takes. It's not even up to, it's just in seconds. You can come to message here to see. That's just about 2 seconds thereabout, right? Now, that's the time it takes. So now just imagine that we have a lot of rows here. This is just 2 rows. So now we have millions, like 100 million rows. It will take time. You just see this, instead of this stuff saying query executed successfully, it will take a lot of time before this query gets executed. So how do you overcome this challenge? So we overcome this challenge, right, by creating indexes. So indexes, let me just explain so that you get the overview. Index is just like, for example, you have a textbook that is about 1,000 pages. Just imagine that there is no table of contents where you can go to and say, okay, you're looking for a particular chapter. You get it now. You can always do what? Go to table of content and okay, you see this is the page. Then you go back to then you just open that page. Just imagine you have to go through, instead of doing that table of content, you now have to go through each pages. You know, it take time before you get there. So, and you have to even read through, right? So it will take a lot of time. So that's what index does. So index will speed up your search. So if you run a select star something, maybe where you now put a where clause, where ages, for example, this table now, when I say when age is 32. So it will go through the table one by one, but with indexes, it makes it faster. So it creates an index and then it makes your search faster. So we have 2 types. We have clustered and non-clustered, right? So as you can see here, an index is very similar to an index in the back of a book, right? Just like glossary. For example, if you want to reference all pages in a book, that's also a certain topic, you first refer to the index, which lists all the topics alphabetically, and then refer to one more pages. Index helps to speed up selects and where clauses, right? It slows down data input with the input and the insert statement. So that's if you are doing any updates or insert statements, but in the long run, indexes are still very good. They can be created or dropped with no effect on the data, right? So it won't have any effect on data because it's just something like you are creating. So as I was saying, we have 2 major types, clustered and non-clustered, although there is also unique index. But unique index is more or less like primary key. Now, for example, this table now, let's check e-test. So for e-test, the primary key here is student ID. So student ID is more or less like a unique index to identify. You get it? So that's why we don't really talk about what's it called? About unique indexes. But the major two types are clustered index and non-clustered index. Now, what is the difference? Now, clustered index helps to it's just like is an index created on that table itself, created on top of that table. So if I have this table now, I can create a clustered index on this. So it's more or less like I'm inserting, not visible, right? I'm inserting another column on this table, and that is performing a clustered index, right? So clustered index will be like you have a book now, right? On the page, on the same page, you have, okay, go to the next. Maybe you are, if you have worked with Word, whereby you when you have a subheading, when you click on that subheading, you can also see things under it, right? Maybe in, so that's how clustering index, or it's just you are creating it on another table, right? Sorry, on the same table, you are creating an index on that same table, right? But non-clustered index, right? Non-clustered index is more or less like your glossary in a book or table of content in a book, because the data, the page or the chapter you're looking for is in another place, another page. Your table of content is in another place, right? So that's not clustered index. That is, the index is stored in another separate location aside from the table, right? So that is not clustered index. Although it works similar in a similar way, but just that its location is different from the table, right? In another location. So someone might want to ask, okay, what's now the benefit? Which one is better? Anyone that works is better. But for large database, I think non-clustered index is better, right? So that's that about index. So like, let's just try it out. All right. So if I select star now, I will discover that it took 2 seconds, right? Now let's create index on this guy. Okay, let's do a where clause, right? I think there was one that okay, let's do a where clause. Let's say where age is 35. You can see, let's look at the time it took. You can see it took what? Took us I think this should even be the second part. I think this is not up to. I don't think it should be up to. It's just it ran microseconds. I think that's like 8 microseconds, right? Now let's come back and create index on this table. How do you create index? The syntax is already here, as you can see. Create, so you can specify. You can say I'm creating a clustered or not clustered or unique index or something on the table and the column name. So let's just do a cluster. Create clustered index. The index name, let's call it ID underscore test. On the what's the name of our table? E-test. Let's specify the column we want to create index on. We want to create that index on age, right? So let's execute this. Okay, there is one already. When? So let's delete this. Let's delete this one. So let's create now. Cannot create more than one clustered index on e-test. Drop the existing clustered index. We've dropped it now. Okay, so let's drop it. So as you can see, if you look at the for drop, just drop index, the index name on table straight away. So drop index, the index name here, let's copy it into C. So you can see what we are saying now. Clustered index, you can see PK, primary key. So primary key is the index it created. So by default, it created a unique, or let's say clustered index on that table directly, which is more or less like the what's it called now, the primary key. So clustered index, now it told us it's created on that table. So by default now, on the table name, by default now, that was the clustered index. But let's drop it. Okay, and explicit drop index is now allowed on index. It's being used. Okay, you can see it's being used as primary key, right? So let's do a non-clustered index. Right, let's see. You can see non-clustered index has been created. Now, if we refresh this, you can see it's now here. It's now named non-clustered and non-unique, right? So it's in another location. Now I want us to try with, let's see, any other one that is there an index on this? Okay, there's already an index on this non-clustered as well. Okay, a customer. Okay, there is no index on customer. Let's select top something. Okay, so great. So let's do select star from customer. Let's see. Okay, these are the data. There's no index on it currently. So let's create an index on this. So now let's do a where clause and let's look at the time where age is 34. So let's run this. As you can see, it is not up to that's microseconds, right? Microseconds, 13 microseconds. Now 13.0. So now let's create an index on this guy. Create index. Right, you can see it's just straight away drop index, straight away you drop it. Create index, the index name. So ID underscore customer. Table name is what? Customer. So the column we want to create index on is, let's say, age, for example. Is that not the name? Okay, it's customers, not customer. Customers. So the query has executed successfully. Now you can see it took 8 seconds. You can see 8 seconds. So I'm trying to look at it here. That's 8 seconds completed time. Okay, 5, 14, 24. 10 is power 1. 5, 14. This is 8 seconds, for example. I want to see that it's, but no issue. So we've created an index. Now, if you expand this guy now, indexes, let's refresh. You see now that we now have an index. You can see non-clustered index. So meaning by default, it creates a non-clustered what? Index, because by default, is there any primary key here? So, but here you can also create a cluster because there is no. So if I say create clustered index, for example, now, in this case, because we don't have a primary key before, this guy, so let's change the name. So this guy, by default, we create You can see now if we refresh key, refresh. Let's refresh indexes here. You can see it has created a clustered index ID on this. Now, if you run this query now, here, it has created a clustered. If you are creating a cluster, you have to specify. If you now run this query now, you see that the time it will take will be lesser. That time, I think it was, can't remember now. But if you have a large number of data, you'll be able to see this, that it did not, time has really reduced. So that's basically what an index does. It helps to reduce the time it takes for you to run. So all this will be sent to us, right? So that's index. So author table, we've talked about that. Right. If you want to change a table, you use author. If you want to change a column in a table, you use update. Very key. So using views. Now, what are views, right? Views are temporary tables. Now, say for example, I told us, I think I told us last week that views are like your calculated table, yes, in Power BI. Because now you have a table, right? And you want to create another table from that table. Maybe that you can reuse, or you don't want to touch that big table, you just want to create a smaller table. Then you use a view, right? Say for example now, so let's run this now. This table now, right? This is table. You just want to where the salary is greater than 30,000, 30,000, for example. Where salary is greater than 30,000. Now you can see the query has what reduced. Now, but this is just a query. Sorry, the output has reduced. This is just a query. You cannot reuse this. If I close this SSMS now, I cannot see this as a table again. So how do I ensure that because I reuse this, maybe you reuse something, so it's better. How do I ensure that it's reusable, right? So I can use a view. So I can store this query as a view now. So what is the syntax? Very simple. Create view. The view name. Let's say our view name is costs or costo. Create view, that's the view name. On, then you can now bring this one close to this. That's all. Create view, the view name on select star from where. So this guy now, when I execute this, what's wrong? Create view. Sorry, create view has create view, the view name as select. So when I execute this now, right? When I execute this now, it has successfully. So when you come to your tables, right? You just refresh these tables, refresh. So if you see, you have when you're under a database, under each database, you have tables. If I minimize this so that you can see what I mean by that. So you have tables, views. So this is where all your views that you created comes. If you come here now, so you see this cost now, you can see. So I can now do a select now, because it's now a view, not a temporary table really, but a sub table that can be reused, right? Select, I can say select star from costo. So if I run this query now, you can see it's now returning for me a table based on this our where condition here. So this table now is now present here. You can see that, but not as a table, but as a view, right? And of course, if you don't want to go through this, you can also, I can, instead of saying create view this one, I can copy this query. I can just copy this select star, the query I needed. I can say Control C, come to view, right click on view and say new view, right? Instantly it will ask you, do you want to create view from this guy? You see, so it's telling you, okay, you want to create that view from this. Let's say you can say add, right? So instantly it will add. Close it. You can see it has added this for you. So you can now specify your query yourself, right? But in my case, I already have my query. I will just paste it and say Ctrl S. It will ask for the name of my view. Let's say I want to name it course. You say okay. So instantly when I come in, I will just refresh and then my view is here. So the same thing, I can now come in and instead of this one, let me change it to SS and run my query and I still have the same answer. So that's how you use it. So V is just to help you. Now I don't need to relate with this bigger table every time because I'm always selecting where salary is greater than 30,000. Let's say you want to do so it's a recurring task. It's better to create a view so that it helps you, or you just need a sub table, right? You just need a sub table instead of you having to create a table again. So you can just create a view and that helps you. But it's a bit different from temporary table. From the name, temporary table are tables that are temporary. Immediately you close your session, right? Temporary tables, when you close, you log out of this, you disconnect your server instance. Temporary table stops. You can't view it again. So that's the difference between a temporary table and a view, right? And temporary table comes to, you can see 10 dB here. So that's where a temporary table goes to. So we discuss that as well. All right, so that's how view works. Let's proceed. So having clause. So having clause, right? So having clause, don't forget you can add comment using what? Triple slash. So having clause is often or is always used when an aggregate function, is what is used. So when I say aggregate functions, so I need to comment it out so that it will turn to aggregate functions include, when you say aggregate functions include maybe sum, average, and they are used to aggregate, right? Mean, max, all right? The aggregate functions. So aggregate functions. Just like you have test functions, right? Test functions as well. To include lower, upper, concat, mid. There's no mid, there's substring, and a whole lot of them. So it is only when you use aggregate functions like this, that's when you use having. All right. So say for example, I say select star from customers, right? When I execute, right? Now I can say where sex, let me see, where salary is 45,000, right? So and that will execute for 45,000. But the moment I want to use sum and I need to pass an aggregate, right? Then I will have to use the having instead of where. I will use having, right? So here now I can use where, right? Where salary. But immediately I use an aggregation like sum, sum salary. So here now I will have to use sum All right. So here, instead of where, now we'll now use having. But of course, there must be an aggregate value, right? I can't just say some. I can say some salary, but it will give me just a value, remember. So it will just sum everything for me. But let's say select age, and sum of salary. Oh, sorry, there is no column as age. Where are those tables? So let me check the columns here. Okay, age is capital letter. So let's run this again. Okay, it won't run because I need to pass. So I need to aggregate it group by. I need to group it by. So I need to group it by. So I have to do a group by first. Remember, group by what? Group by age. So you can see we're running. So it has grouped everything. Null is this 34, 50, and then it has grouped it by now. So if I now want to select, this is sum, Abby. Is sum all null? Sum all ages at 34, sum all the salaries of ages at 34, some of the salaries of ages at 50, all the salaries of ages at 67. Now you have to do a group, use a group when you are using aggregates, right? That's very key. So now let's now say you want to select where this guy here is 60,000. So you can't use where. In this case, you have to use having. So having some, so you now call this guy again. You can copy it, right? Having some, some, let's say greater than 60,000. So when we run this now, it will just return 1. You can see this is the only group that is greater than 60,000. Now, remember there is no column here. You can do what alias, remember, as I told us, as let's say sal sum, sal underscore sum. So I run this now, it comes with a name, right? But someone will want to say, why can't I use sal sum here? You won't, it will give you error, right? You won't be able to use the alias when you are using the having, right? So if you run this, to give you an error. So you have to call that aggregate, right? V, and then that works fine. So that's how having works. You use a group by then having, right? So, but that does not stop you from using a where clause, right? But your where clause must follow the first statement. So let's do something. Let me just copy this first one so that you see. Control C. V. So let me do a selector and still run this guy together. Right, so that you can see. So you can see I said select start from customer. I have this. Select, let me give a space. Select each sum of salary as sales sum from customer group by age, having some salary greater than 60,000. So if you look at this now, I have already said group it by age. Now sum the salary. So wherever it is 34, it had 3,000 plus 3,000. So it had one age, 34, 60,000. 67 is 2 to 67, so it add this to 90,000. 50 is just 1, 23,000. So that's the group by. Now, if in case I don't want this 90,000, so I can say I can put a where clause here. I said where salary is greater than 60,000. So you see, okay, let me say where salary is greater than or equal to, right? So look at this query now, it will return 2 now because one is 60,000, one is 90,000. Now, if I just wanted to return this one here, right, I can do a where clause before the group by. So I can say where age is not, I can say where age is not 67, for example. So it won't count 67 as part of it. So I can say where age is not what But you know we want to say it's not, so you have to put the not at the part where not age is 67. Where age is 67. So to say not 67, you have to put the not at the part. So in this case, the query will just return 34,60,000 because this we've removed this from our query already. From this large table, we've removed 67. So it will now do an aggregate. So that's how you do. So let's run this now. You can see now it's just returning 60,000. Then we now say group by. So this is the order. Select the where, the group by, the having, right? Not where at the last. So you can now, after this now, having, you can now say, let's remove this guy, for example. Let's remove this one again. All right, I can now do a what? Order by now. Order by, you can say order by age, descending, for example, so that 67 comes first or something. You can see now 67 and then like that. So that's how having works, right? So transactions. So what are transactions, right? If you remember from your knowledge of banking, you've noticed that there are times so you will notice that there are times that you want to make a transfer, right? They've deducted your money. And the person is saying, I've not received it. But you received that, they deducted your money. First day pass, second day pass. What's happening? You start panicking. I will contact my bank. What's happening? I will contact my bank. I have to contact my bank. That's why did they deduct my money, right? So what is happening in that case is still the database. You notice that maybe after you just see your money, bam, even without contacting your bank, sometimes you just see the money. They've deducted my money, you now resend. What is happening in that case is transaction, right? Transactional SQL, right? What is happening is your money, how transactional SQL works is there is no complete transaction in SQL without, so you send the money, right? But the person has not received it. So you are customer A, the person is customer B. You are sending from A to B. So B has not received. A has received debit. So meaning A is true, meaning everything about A has been executed. B is what is not true because B has not received the money. The money is sent the money. So because both is not true, it will return your money back. So that's how it's done. So we call that a commit. So when you are sending that money, right, and they deducted your money, so your money, like your balance in your account will reduce. SQL, like the database has what reduce your money from 10,000 to maybe 5,000. Maybe you sent out 5,000. So your balance is now 5,000. It has committed it. You cannot change it and say, no, change it back to 10,000, just like that. Because if you did it like that, if I send you money and you didn't receive it, Abi, right? Or let me say I sent you a fake, I sent you money, you didn't receive it, and it has been deducted from my end. So I can show you, right? I can show you my message. They've deducted me. But if I have power over balance, I can always go back and say, okay, give me back my money. I will prove it to you that I've sent that money, right? So that is how SQL works. So in that process that you sent out the money, SQL has what committed that query that you cannot make changes. Now, because the other party is not yet true, that process is not yet finished because that other person has to receive the money. If not, what happens after a while, right? What does happen after a while? Why you receive that back your money is because so far it's not going to the other party. The other B is not receiving it. So it will do a rollback. So it will roll back your money, right? So it will just roll back your money and you say, wow, I've received my money again. They've transferred back my money. So it's sometimes nobody touched it. You see that you didn't contact your bank and it's just happening on its own. So that's how it happens. You don't need to contact your bank sometimes if the person has not received it, if there is network issue. So why is all this necessary? Let's say you have network issues. Just imagine your data just finished as you are sending money and you sent it already and they detected. All right. So that's the benefit of this. So it helps. So I will just give us the query and then how it works, right? For example, let me just read through. A transaction in SQL Server is a sequential group of statements or queries to perform single or multiple tasks in a database. Each transaction may have single read, write, update, or delete operations, or a combination of all these operations. Each transaction must happen two things in SQL Server. Either so in a transaction, either all motivation is what is successful when the transaction is committed, or all modifications are undone when the transaction is what rolled back. So you can't have half done. So that's why a bank does not need to interfere. Just so don't worry, they will revert it. Like yesterday now, I did a transaction, right? And it went to the deducted me and there's nothing. I just tweeted this morning, it didn't just delivered. Immediately it delivered, everything works fine, right? So this statement is saying a part cannot be successful, all must be successful. So you can see a transaction cannot be successful until all of the operations in the set are completed. It means that if any argument fails, the transaction operations will fail. Each transaction begins with the first executable SQL statement and then it ends when it finds a commit or rollback, right? Either explicitly or implicitly, right? So when we say explicitly or implicitly, it could be maybe by default, or maybe the database person has to go and do a reverse. So when everything turns to it's still not coming back, then the database engineer can now confirm that is it true that this person sent the money? Okay, it has not delivered, and can now do a rollback. So that's what it's saying by when it finds a commit or rollback. So the person cannot do an implicit rollback or commit. All right. So sometimes you send money, all right, and the person has you and you yourself you didn't receive a lot. You won't receive a lot. So a database person can now come in and do an implicit rollback or commit. So explicitly is what it does by default when it sees that everything is fine. It uses the commit or rollback statement explicitly as well as implicitly when a DDL statement is what is, you can see now, data definition language. So implicitly is now done in, but explicitly by default, right? So 4 things that you need to note on database is ACID, atomicity, consistency, isolation, and durability. This is the backbone of transactional SQL. So what do we mean by this? ACID, 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 right? So this property ensures that all statements atomicity from the concept of atom, the smallest particle of an element, right? So smallest particle of an element. One, each, you can see, all statement operations including interaction must be performed successfully. Otherwise, the whole transaction will be aborted. All. And all operations are rolled back into their previous state when any operation is failed. So there is no part in the execution. Though it's just explaining that both transactions, both the sender and the receiver must receive their money before we can say yes, transaction is complete. Consistency. Property ensures that database changes only when transaction will be committed successfully. It's also responsible for protecting data from crashes, right? Isolation guarantees that all transactions are isolated from other transactions, meaning each operation in the transaction is operated independently. It also ensures that statements are transparent to each other. So what is the essence of this? This is to help to track, right? So when we say isolation now, on my own, I've sent the money, I've been debited. That's isolation on my own. On your own, you've not received it, and I said I've sent it. So we can now trash now. We can now debug. Okay, what's wrong? It is from your own side. I need to debug now because from my own side it is sorted that I sent it and it's been deducted. So that's why isolation. Just say in case there is no isolation, you have to now check through each of the transactional process. which will take time. But with isolation, every operations are independent. Durability, this property guarantees that the result of a committed transaction persists in the database permanently, even if a system crashes or fails. You can see now. So durability is even if the database of that bank, right, fails. You can sometimes you see that they will tell you our network is down. Please stay tuned. When you are doing any transaction by that time, sometimes some people it will go, but the person that you sent it to did not receive it. And you say, maybe you now receive a message later. Our system has broken down. Or this, and this. And, I'm in trouble. How do you? Even though their system is down, durability says when the system is restored, everything where that transaction stopped, that's where it's going to continue. So that's which is very important, right? So that's what the durability is saying. Result of committed transaction persists in the database permanently, even if the system crashes or fails. So very quickly, this is just like the syntax. So to start a transaction, you can say, okay, for example, I want to do an insert. For example, look at this insert statement. I will say begin transaction. Then my SQL statement. To start a new transaction, you begin, right? And then the SQL, let's say I want to insert. For example, now, let's say you want to withdraw now, you can say select, you get it now, select where, how you do a subtraction, select 20,000, for example. I'll give us an example now. This is just an example, this. Then how do you now commit what you have just done? Commit transaction. Let me give us an example. Look at this table now, for example. Okay. Select, let's say, age from customer, where salary, where age is 34, for example. So I can say select age, salary. I have to do a group by. So let me remove all this first. Where age is 34, or let me use 50 so that I won't get to where age is 50 by age, right? Just say salary. Let's not use a group by. We don't need a group by for now. So we don't need a group by. So look at this now. What do you have selected? It has selected. So let's now say salary minus 10,000. What's happening? So let's say I am transferring money now, right? I've transferred 10,000. What should be my balance? 13,000. So what do? I can always say begin transaction, right? And then this is my statement. And after that, I will say commit transaction. So if I run this now, sorry. So you can see now. So by default in the system, what this is saying is my money will not change. It's not that the 10,000 will now come back to my money now, it will be 23,000. No, nothing will change in my money again, because I already said begin transaction and I already said commit it, right? So that's how this works, right? And if you need to roll back, just say roll back. So if you are doing it explicitly, just and it will. So to roll back your money, if you need to roll back, maybe one of the processes are not were not executed, so you can roll back. So that's basically transactional SQL. So you do this transaction and that works. Now, wildcard operators. So wildcard operators in SQL, there are a bit of them. Let me just list out quite a number of them. Okay, let me use this first. So wildcard operators. Now, one of them is this, right? What does this mean? We are saying if I put OA and I say B O like this means you can return either both or but. So I'm saying search from my query wherever you see O or A and the word start with B and end with T. If it is O or A that is in between, then return it. Any other thing from O and A, don't return it. That's what this means. Now, if I put, let me copy this. So if I put something like a greater than facing up, I want to see that special. Okay, yes, it's there. So if I put it this way, I'm saying return any other thing except return any other thing except the one that has O, like BOT or A. So you can return anything like BET, BIT. All right. It could be more than 2 letters, so it could be, right. I'm saying return anything except OADE that is in between. It must start with B, it must end with T. Right. That's how this works. And you can also do a range, right? Instead of OA. So I can say from A to E. So what I'm saying is that if the letter is between, so I can say BAT, BBT, in this range is still correct, BCT, BDT, or BDT, BET, right? So anything around this is acceptable. That's what this means. And if I put an upper stop there, that means anything aside this is not what? It's only anything that is aside this that is acceptable. Anything aside this is not. Anything in this range, sorry, is not acceptable. So that's that. These are wild characters you have. So this is for range. This is for you are looking at each letter, comparing them. And then, of course, you have this as well. So I can say, so what this means is T. So look at anywhere. Maybe you are looking for people that are Atere, Otebo, Etebo, Iteng, names like that. You want to search for names that have their second letter as T. So this underscore here is the first letter. It can be anything. But what I'm concerned is the second letter must be what? T. So let's say I want Hatere, Etebo, and all that, etc. That is, the second letter must be what? T. It can be in the reverse order as well. It could be T, right? So what this is saying is that it must start with T and one letter, just one letter must come after it. So it must be maybe to TB. It can never be what? TBT or TBR, because it now has two letters in front of T. It's saying just one letter after it, right? That's one. And then you have the percentage, right? So I can say T percentage. So what this means is I don't want to know how many letters this has, but but that word must end with T. That's what this means. So it can be Ade, Adebat. It can be bat. It can be oat, right? But the cocoa is all the words must what? Just want to see all words that end with what? T. So also it can be in reverse. I can say all words that start with what? T, right? And it can be how many, no matter the number of characters, you can see. But it's different from this one. Remember, this one is just one letter must be in front. This one, just one letter must be in front, just behind. It was one letter, this letter must be behind. So these are some of the wild characters you have in SQL. So let's do that with examples. All right. Let's clear out this. Let's select star. No, this one does not have name. I think one of our table has name, right? E-train. Let me see train. EDDL. Okay, so let's use this. So with our example now, I can say select star from this table, right? This is our select star, but I want to where. So it's your white characters are always used with what? Like, right? So where name, where like. So I'll have to put it in single quotes, where name like. So if I want the second letter to always be E, for example, that is going to be only Shegun, right? I will have said we should insert more. So, but you can practice that out. So I want the second letter to always be E. I can say underscore E and close that. So where the second letter is always E. So if I run this now, oh sorry. So and now I will now put percentage. That is, I can have another anything in front, right? I can have letters in front. So you can see now it's returning Shegun because it's only Shegun that has the second letter to be E and any other thing in front. So you can see it's returning for Sheg and Shegun as well, right? But if I say it must be 3 letters, that's what I'm saying. If I do it like this way, it must be one letter in front, E must be at the middle, and then one letter. In this case, it will only return Sheg. You can see now it's only returning what? Sheg, right? If I said it starts with S and anything can be in front, you can see. So it returns Shegun for me. Let's comment out. So you can also comment out query so that part is not, you can just write 3 hyphen. That part is not executed. You can see here now, you can see that this is all. Let's say GD now, it starts with GJ, for example. Just say G and any other thing. You can see now. So I say it must end with D, for example. I want to see the ones that ends with D. I'll just, so it will only return D, right? So let's say I want to, where it is like, let me comment this out, or let me duplicate this, Control C, Control V. Let's run this together now. Yeah, let me run this first so that you can see. So now I want to say, okay, either I or D or E is in between. So let me say it starts with anything. That's what this means. And either I or E is amongst what is and then let me now say then other letters again, any other thing, then it ends with what? N. So in this case now it will return Shegun, right? It's only Shegun that started, it has I or he, either I or E, right? And then it ends with N, right? But if I say any other thing, I or E, and it end, I didn't put this. If I run this, you can see now, either I or E, it started with anything, but what I'm saying here is it must end with I or E. So if I put any other letter in front, for example, it will return almost everything, because now I didn't specify what it must end with. I just said I or E must be something around in the middle, and every one of them, Jide has I in the middle, Shegun has this. So this is how special characters, white characters works, right? And it tells, what do you need this for? It tells to speed up your search. You're looking at a table, but you are looking for a pattern. Okay, maybe email, for example, right? I want to look for a particular, you have Gmail, you have a company that is using Gmail, that is using Outlook, that is using different kind of mail. So I can say where email like, so, and it's always sending at gmail.com. So I can say %.com. So I'm saying it must end with what? .com. Anywhere you see .com at the end, then return it for me. So that's how the use case of this, right? So white characters. Then we discussed about date functions and temporary tables and clones. Maybe in the next class we take the last three subqueries, using sequence, and duplicate and rejections. Or I will just take the very fast ones. So quickly, let me take date functions. We might spend a bit of time. Let's go to temporary tables. So right, from here, so temporary tables, like I said, they are just tables that are temporal. Let's just read through what we have here. You can see a temporary table in SQL is a special table that cannot be stored permanently, right? So this table keeps offsets. You can get through. So it's not permanent. It's when your session ends, that table ends. And what is the an example? So in case this is an example, the only thing, remember, if I want to, okay, so let me treat these two together, cloning a table and then temporary table. Now, remember, if I want to clone a table, when I say clone a table, now look at this table. Look at this table. This is our EDDL table, right? We want to clone this table. That is, I want to duplicate this table. I want to have another copy, right? What do? I will just say select star into, I will name the name of my clone table. Let's say is EDDD. EDDD from what? E_DDL. So I've just, with this query now, select star into, so I'm creating another table called EDD that has all the data from here. When I run this now, it's done. And then if I say select star from EDD, let me remove this. So what does that do? You can see it's returning the same. So I've just cloned this table now with this statement. Select star into, right? I might not select star, right? I might say select star, select age, select age into EDD from EDDL, all right? Let's put a where clause. I think where age is greater than 15. Let's see. So let's change the table name. That's what this guy is saying. Edo now. You can see now. So if you run select star from Edo now, You can see it just where age is greater than 50, it has returned 32, 32. So this is how you clone the table, right? So, and it's more or less like, now you're cloning that table. It's different from view. Remember, view, you have to check it under views, right? Under the view part. But for cloned tables, let me refresh this. You can see that you now see EDD now. You see EDD and IDO that you just created. Now, to create a temporary table is similar to what you have here, except that if it is a temporary table you want to create, you have to initialize this with hash. That's the only difference, right? Immediately you initialize it with hash, SQL knows that, okay, you are creating a temporary table. So when I run this now, you can see, now if I refresh, you can see it's not giving me error, even though I have IDO before. You can see IDO is not here. But when I come here now, right, and I change this to, let's say, 10 dB, this is where you see it. Now, or let me not change this. Let me just adventure works. Now, these are my databases. I'll come to system database. You can see system database. All right. So you can see 10 dB now. So if I check, if I refresh this, let me check temporary tables now. You can see I have my temporary table here, right? You can see my temporary table is here now, meaning it's a temporary table. I can also, so I can do select star from you can see now. So it's stored there. That's the only difference. So those are temporary tables. That's how a temporary table works. So just initialize it when you are doing your cloning. That's that about temporary tables. All right. So I've talked about clone tables as well. I've talked about temporary. So cloning is just that you are making a copy, right? Then I also want to call about sequence now and injection. So let me talk about handling duplicates. So let me bold this out. This is sorry. Let me bold this. This is what we've not treated. All right. So lastly for today, let me talk about handling duplicates, right? Which is subqueries, right? Now, what is handling duplicates? For example, it's just about selecting distance. Now, look at this data. Okay, so let me join this guy together, right? Remember our union all? I'll just say union all, right? Let me now Control V again. So what does this do? Remember, it will just add everything together, all right? You can see, but if I say union, what will happen? It will just return that same table. You can see unique ones, but union all will say, okay, add everything together and it will duplicate. We have lengthier amount of data now, right? Now, like as you have this, let's now let's do a, what's it called now? Sorry, handling duplicate, right? So if I make this, now if I make this is not a table yet, it's just a query, Abi. I can make it a table, right? How do I make it a table? I can do what? I can create a view with this. Remember, right? I can create view so that I can now, this will now become a table, and then I can now use duplicate to remove duplicate from here. So I can say create view what? doc as and then run this. So if I come to my views now, let's go back and go to our Adventure Works database and go to my views. Let me refresh this. Now we now have, you can see I now have doc. So if I say select star from doc, all right, let me run this now. You see that now I have this as a table. Now let's say I want to remove all those duplicates. You know, we have one schedule 15, one schedule 15 twice. We just want unique ones. So I can say distinct. I will just add distinct in front. You can see instantly it has removed duplicates from my data. Anywhere, all the records are the same. One schedule 15 to remove it. All right. Let me run boot so you see. Oh, sorry, I'm not running. Let me run this, just these two. You can see now, one schedule 15, one schedule 15, two GD 14, two GD 14, to retain just one record. So that's how to deal with duplicates. And if your aim is to, for example, from this table now, from this adopt, we just want to select distinct customer ID. You can also do that. So I can say select distinct, put that into what? Student ID, right? Comma and name from doc. Sorry. You can see. So it has selected unique ones for me. So from that table, each. So these are the only unique student ID. So that's how you deal with duplicates, because sometimes your data has duplicates. So you must learn how to use the distinct word. Now, lastly, so that's how you handle duplicate. Lastly, let's talk about subqueries, and then in later class or during one of our sessions, right, we'll discuss about date functions using sequences and injections. All right. So let's talk about subqueries. Now, subqueries is just about, so let me use customer table. Select star from customers. For example, let me select. Now, this is our customer table. So let's say I want to select okay, let's say, let me give us an example like select salary from customers, right? Now I can do where I can do a select statement where select star from customers. Select star from customers where age is greater than 50. Now, expression of non-real transfer in where condition is Okay, so where where I'm trying to where date. Oh, okay. Let me see. Where age is equal to where age is equal to select star from customer where age is greater than 50. So this guy here, the first query that will be executed is this part. So this part now, if you do this, it's saying select star from customer where age is what greater than 50, which is just here. Now we are now putting, instead of saying where age is 67, we now want to use a subquery. This is what we're using. So what's the salary that will return now? 45,000. So if you remove this and run this, when the subquery is not really with exist. Okay, where age, okay, let's say select distinct. Let's do a distinct. Let me run this now. If you say do a distinct now. Now we can't select star. Let's just select, let me say select age. Select age. Now if I say select age, where age is greater than 50, this inner query, let me execute. You can see, but I need distinct, right? Distinct to just select one age. Now if I run this inner query, this return what 67. Now I can run all of this together, right? Because because this query here will give me what? So instead of passing in 67, when I select distinct age from customer where age is greater than 50, I've selected distinct age and it's returning 67. This query here will return 67. And I said where age is equal to. So it's as good as saying where age is equal to what? 67. And that's what so this is a subquery. We have a select statement and we have another select statement here. So you can see how this works now. Now I'm doing a subquery. So I'm saying where age is 67, but my answer is not correct. I'm not putting 67. I'm using a subquery. That's what we mean by a subquery. Now this select can be anywhere. I can say select salary, comma. I can do my subquery here as well, comma. This will be in bracket now. But I can't use a distance. I can say select age from, right? So let me say I'm putting out this now. What is this guy saying? So I'm saying select salary and select age. Where age is, but I'm doing it using it as query follows. Okay, okay, let me just correction out this. Let me run now. Select age from customers. So there are times you have to do it this way as well. I'll look for more examples for us to treat with on that subquery, right? But that's just an idea. This is an idea of what a subquery does, right? You are doing multiple select statements inside your query. That's what a subquery is. So a subquery can be more than two, right? Select salary from customer where age is equal to select again. So I can still do a select, but the thing is, it's always good to start from what? Bottom up. So bottom means start from what you are expecting, put in your equal to or something, and they'll do that, right? I will look for more examples on subqueries during our session so that we can treat that, right? So well, that's basically what is subquery. It's just that using two queries inside a query. That's what it means by subqueries, and it's very useful, right? We'll treat some examples during our live session. So I will draw the curtain here, all right? So we'll get the videos, and then I expect us to practice and then do our live session. Questions, just bombard, come with questions, come prepared. That's the best way to learn, right? So see you. Bye. So by the last class, we do date functions using frequency during our live sessions, right? Thank you. Bye.